Now we will quickly go through the different attribute selection measures. We have to see three attribute selection measures, including information gain, gain ratio, and Gini index. And different algorithms use different attribute selection measures. For example, ID3 uses information gain as its attribute selection measure. You will see some formal definitions as well as the notations. You can skip all this, but for understanding the concept, you can read it as and when required. I will explain only the necessary points using these slides. We have to calculate the information gain of attributes with three equations, with three formulas. Here we have to first calculate the info of D, that is the partition, data partition. We have to calculate the total info of that particular data partition using this particular equation. Here the Pi is the probability that an arbitrary tuple in D belongs to class Ci. The classes may be C1, C2, etc. And what is the probability that a particular attribute will belong to, for example, to class C1 and or it belongs to class C2, etc. and is estimated by that particular class values, that is the total number, that is mode of CID divided by mode of D. Mode of D means total number of tuples in the training set. A log function to the base 2 is used because the information is encoded in bits. Next, we have to calculate the information of this particular data set based on that particular attribute. So, the info of A of D is calculated using the below equation, that is sum of j equal to 1 to v, and we are finding the jth partition, that is dj mode dj divided by mode of d into information of dj. This is the equation for calculating the information on data partition based on that particular attribute. The info of D is also known as the entropy of D. We have to calculate the gain of each and every attribute. Information gain of a particular attribute is calculated using this equation, that is info of D minus info of that particular D upon particular attribute A. So we have to calculate the gain of each and every attribute, and the attribute A with the highest information gain is chosen as the splitting attribute at node N. So this is the way we have to calculate the information gain. Now we are seeing the example. Here we will see how we are constructing a decision tree based on the attribute selection measures. Here you see the table 6.1. We have a set of training tuples which are class labeled. Here we have two different classes that are bias computer yes and bias computer no. So these are the two classes here. You can represent it as C1 and C2. And here how we are calculating the info of D using the formulae. Here we have total 14 training tuples, that is the total number. We have represented here as 14 in the equation, and the 9 represents the total yes cases, and the total no cases we have to see separately. And here we have the bias computer yes comes in 9 tuples, that is the value represented here, and the 5 represents the no values. So the positive case and the negative case, or the different class values are separately representing here while we calculating the information on particular data set. And finally we get a value of 0.940 in bits. So that is the info of D based on this training tuples. Then we have to calculate the info of D on each attribute. First, we are seeing the info of age on this particular D. Total we have youth. Age is divided into three categories, that are youth, middle-aged and senior. We have 5 tuples with age attribute youth and 4 tuples with age attribute middle-aged and 5 tuples with senior category. So that is represented here as 5 by total number of tuples, that is 14. And here also we have to see the positive, the yes cases and the no cases. Here we have 2 tuples with a youth category will comes in class yes, and the 3 tuples comes with class label no. So that is represented here. Among 5 tuples we have 2 yes cases and we have 3 no cases. That is represented in the first line of this particular equation. Then we have to see the same for the middle-aged and senior cases. Finally, we get a value that is 0.694 bits. Then we have to calculate the gain value, gain of age, that is the info of D minus info of D based on this age. So we get, we have these values with us, 0.940, that is the info of D value, and info of D based on age, the value is 0.694. Here we get a information gain of attribute age as 0.246 bits. So this is the way we are calculating the gain of a particular attribute. Similarly, we can compute the gain of other attributes, that are income, student, credit rating, and if we have more than these attributes, we can calculate the gain value of each and every attribute, and we have to choose the highest information gain attribute as the splitting attribute. Here we have the highest value with age attribute, that's why we have selected it as the splitting attribute. So this is the procedure we are using for having the decision tree, and this is the attribute selection measure we have used, and I hope you understand the concept very well. Similarly, so this is the pictorial or the diagrammatic representation of the splitting attribute, and we are choosing this age attribute as the root, and we have different categories like this. Then we will select the gain value of the particular branch again, and we will repeat this procedure, and based on this we will create a decision tree. So this is the procedure, and we can calculate the information gain of attribute on continuous valued attributes. That is the case of prediction. We can use a different equation for this. We have to calculate the midpoint between the values, and this is done using the below equation, that is AI plus 1 divided by 2, and I'm not explaining it in detail because we have to know how this particular measure is used in calculating the splitting attribute. Then we have gain ratio, and gain ratio is also calculated. The information gain measure is biased toward tests with many outcomes. So it prefers the select attributes having a large number of values. So this gain ratio is calculated using this particular equation, that is split info of D on a particular attribute. This is the equation for calculating the gain ratio, and The C4.5 algorithm, which is the successor of ID3, uses this gain ratio measure, which overcomes the disadvantage that comes with the ID3 algorithm. So this is the equation. I'm not explaining it again. And we can calculate the gain ratio of each and every attribute using gain of A divided by split info of A. Here you have examples here. I just kept all the points here. If you are interested, you can go through this. You have to calculate the split info of A and info of D using the same example.